Alright, time for another debatephysics.com, also draftphysics.com. But this is one in a series of videos on simple concepts that debunk the idea of kinetic energy, or the theory that energy is best described as 1/2 the mass times the velocity squared. And that the real equation is Newton's equation and Galileo's equation and, say, Descartes' equation of just mv, mass times velocity, equals the quantity of something's motion, the energy it possesses, the force it has acquired. And so in the history of the science, I say mockingly, there was a period in the 1740-ish range where this theory was resurrected by a person called Madame Chartelet, and she was tutored by a Leibnizian, and so Leibniz was the one who invented the mv squared, the first to publish it as a hard theory. Anyway, and so she caught on to a series of experiments that gave this impression, okay, that there is 4 times the energy in something moving twice as fast. Now, she didn't show that it took 4 times the fuel to go twice as fast or anything obvious like that, but they did come up with these experiments. She took them from another guy who was also a Leibnizian. Okay, so the effort was to resurrect this theory. Now, the simple argument is they dropped round things into clay, okay, and they did get the result. That is, 1x produced 1x the volume of displacement, and 2x the speed with the same mass did produce 4x. Okay, so you got 4 times the volume of displacement in the clay. So yes, it looks like. Alright, but the simple thing to do would be just do the experiment with square objects instead, cylinders with a flat bottom that have a consistent linear bottom. So the idea is you want a way of extracting the energy that is equal, that's always the same. The same mechanism is being applied. So the simple point can be made is round things are essentially a kind of wedge. It's just a dull wedge, a wedge that progressively changes. And that's the key word, it progressively changes. It's a different angle depending on how deep you go. So if you go deep into the clay, you're pushing a lot of clay sideways. You don't go so deep, you're doing a lot of down instead of sideways. So it's kind of obvious that the circle has a shape to it, technically. Alright, and you can understand that that shape is like an arrowhead that constantly changes. If the arrowhead has changes in it from one experiment to another, you're going to get different results. Now, obviously in this case, the more shallow you go, the more of this you're going to do. A lot more down and over, right? You're going to be doing down and over. And then when you're deeper you go, the more sideways you're just going to be doing. So you're going to do more work, okay, because you're pushing down and then sideways to displace, where in the other case, the wedge, the other angles of interaction, you're going to be pushing clay in just one direction. You're not going to have to do the direction change. You're not going to have as far to push the clay. You're not going to be pushing it down and then over. It's a bigger, longer line. Anyway, so if the experiment was done correctly, these can be the expected results in the sense that you are actually using a linear surface, and you'll get a linear proportionality, which is 2x the speed, you'll give you 2x the compression, 1x, 1x, instead of this illusion, or, you know, it's a fact that happens. It's just that it can't be taken too seriously because you can understand that shapes matter. Whether I put an arrowhead on an arrow makes a difference. And all that's being pointed out here is that if the 2 arrowheads, okay, aren't the same, and it's factually not the same to go this deep versus this deep, it's just factual that there's more arrows going this way and this way here than there are here. Here there's more arrows going down, and it's a pretty easy argument to understand. Now, I would argue that that's physics. Physics is recognizing these subtleties and applying them to what you do in your experiments, and understanding how, yes, you can't do the experiment this way where the objects don't penetrate through the clay and equalize. If you made these objects go deeper and deeper into the clay, then this effect becomes less and less important, because it's a smaller percentage of the penetration time is doing this. Yeah. It's a pretty easy to understand mistake, but it is a mistake. It was a mistake to say, okay, we're going to be fooled by this. We're going to be fooled by the round surface, and we're going to think it's extracting energy evenly. So a nonlinear surface doesn't take energy from an object in a linear way, where a linear surface will. And it's almost that obvious and simple. And we're just going to have to wait forever for anybody to draw this and explain how the truth is something different, as with all the other videos. The defenders won't show up for this argument. Okay, so till the next time and such.